Welcome friends, welcome to this fourth series of replacement theory lecture. So in this lecture we are going to study about the model 4. We already have started discussing about model 4. So what is model 4? Model 4 is nothing but the individual or group replacement theory. So we'll look more into detail. We will also solve some examples based on model 4. Then we will also introduce some staffing problems. See, this is not in GTU syllabus, but as an extension of some problems, we can solve with the help of replacement theory only. We will also see some of the examples. Clear? So let's start. So we already discussed about individual or group replacement. So two situations are there. In this case, first is individual replacement. In this policy, what the company will do, see in the last case we decide about we also saw the case of a company which has 1000 bulb installed. Clear? Now in that case, what the replacement policy was to replace the bulbs individually, as and when they are failing, the company will replace them. Clear? So that is the first policy. It says that the item is replaced immediately after its failure. Once they fail, the company will replace them. And the cost was roughly around 31 rupees per bulb. Yes, if you remember that. Now, what is the next policy? The next policy focuses on, imagine that after fixed interval of time, let's say for example 7 months, what the company will do, the company will replace them in a group, right? All of them at the same time after 7 months, say for example. Now, sometimes what happens is replacing them in a group provide benefits to the company rather than going to the individual replacement. So we will discuss this through the examples only. So let's start. Now here is the example is given. In week 1, percentage of failing by the end of the week is 10. At second week 20, third week 50. At the end of fifth week, almost all the bulbs will be failing. So this is the probability given, right? Now this is just an example, right? And the company has given this data. Now what the company wants to do, they have 1000 bulbs installed and cost is 10 rupees for replacing one bulb. And if they are replacing in a group simultaneously all of them, then the cost is 5 rupees per bulb. Now it is proposed to replace all the bulbs at fixed intervals, whether they have fixed or not. If they are fixed or not, you have to replace them, all of them at the same time. And then continue replacing fused bulb, or you can say failed bulbs, as and when they fail. Means, let's say for example after 3 months, suppose 5 bulbs are failed, so you have to replace them. And after 7 months, if the company has to replace all of them. Now out of these policies, which policy is economical for the company? So let's start. So this is the data given here, right? So let's start with the solution. Now what is the average life of a bulb in week? Which is nothing but probability of failure at the end of week into number of bulbs. So what are the number of bulbs? 1000 bulbs. So what we will do here, 10 upon 100, that is this first week probability, plus 2 into 10 upon 100, right? Plus 3 into 30. So how do you get this 10? This is cumulative, right? Here if you do individually, 20 minus 10 is 10, 50 minus 20 is 30, right? 70 minus 50 is 20, and accordingly. Clear? 100 minus 70 is 30. Clear? So you find out individual month probabilities. So it is coming out to be, and you add them, which is coming out to be 3.5. This is the value. Now average number of replacement is nothing but number of bulbs. What are the number of bulbs installed? 1000, right? And what is the average life? Average life is nothing but, this is the summation of individual weeks, so which is nothing but 3.5, which we already got on the top here. Now 1000 divided by 3.5 is nothing but 285 per week. That is the average number to be replaced in a week, right? Now what is the cost? The cost of replacing one bulb is 10 rupees. So obviously for 285 it is 2850 rupees. Okay, this is the total individual replacement cost. Now let's start with the group replacement policy. We already did in the algorithm, but here careful here, each and every step is given and you have to remember the formulas as well. Now let's suppose N1, N2, N3, N4 and N5 are the number of bulbs being replaced at the end of first, second, third, fourth and fifth week respectively. What do you mean by that? It means that N1 is nothing but N0 P1. What is N0? At the starting of the week, the installed capacity was 1000 bulbs. Into what is P1 here? P1 is the 10. It is 0.1, right? So when you multiply both of them, you will get 100. Clear? Understood? So that is nothing but the number of bulbs in the beginning of first week. Clear? Now what is N2? Which is nothing but number of bulbs in the beginning multiplied by probability of bulbs failing during the second week. What are the bulbs that are remained in the second week? When they are failing, you have to multiply that probability with the number of bulbs. So what is the formula here? The formula is nothing but N2 equal to N0P2 plus N1P1. How would you remember this formula? It's nothing but you increase this subscript 0, 1 for N and you decrease the subscript for probability P2 plus P1. In N3 you have 0, 1, 2 increasing subscript for N and decreasing subscript for P, P3, P2, P1. Clear? And accordingly you will find out the number of bulbs for that week. Now for second it is 110. For the third it is 321. Now for the fourth week, accordingly, how will you come about this formula? 0, 1, 2, 3 in increasing order and P4, P3, P2, P1. We have already found out, we have already got P4, P3, P2 and P1. Clear? And again, we have already found out 3, 2, 1 and N0 is again 100. We have already found out N1. We have found out from the previous slide. If you can see here, N1 is 100, N2 is 110 and 3 is 321. You put those figures here and you will find out N4 which is 273. Accordingly you will find out in the same way N5 which is coming out to 413. Now you prepare this table here for the group replacement. This is for the group replacement. You will write in the first column you write end of week, right? Next you write down number of bulbs failing, which we already found out in first week 100, second 110, 321. Clear? Now what do? You will do the cumulative number of failed bulbs. You add, first of all it is 100, 100 plus 110, 210, 210 plus 321, 531 and accordingly. Clear? You will find out cumulative number of failed bulbs. In next column, you will find out the cost of individual replacement, right? You already know what is the cost of individual replacement. It is 10 per bulb. So multiply 10 to all of them. So 100 multiplied by 10, 1000. 210 multiplied by 10, 2100 and accordingly. Now what is the cost of group replacement? If you have seen here, it is 5 rupees, right, per bulb. So there are 1000 bulbs. So what is the total group replacement cost? It is 5000. Clear? Now what is the total cost? You add both of them. 5000 plus 1000, 6000. 7100. How do you come about this value? 5000 plus 200, 2100. That is 7100. That is the total cost. What is the average total cost? How do you find this? If you remember, you divide the total cost by end of the week. That is here 1. 6000 divided by 1, 6000. 7100 divided by 2, which is 3550, and accordingly you will get these values. Can you see the trend here? Yes, it is decreasing, decreasing, decreasing and increasing here. So what is the optimal week? Optimal week is at the end of 4th week, right? And what is the value here? 3260. What was the value for the individual replacement? Yes, it was rupees 2850, and here in group replacement you have got 3260. So which is more beneficial? Definitely it is more economical to follow the individual replacement policy. You might be thinking that obviously all the time individual replacement policy will work out to be beneficial, but it is not the case. Sometimes it is beneficial to do the group replacement as well. Now let's start with the staffing problem. It is one of the recruitment problem you can solve with the help of replacement theory. Now here the team of software developers at this website Universal Teacher, they are planning to rise to a strength of 50 people, right? And they remain at that strength with the following data. Now the data is given at the end of 1 year, right? How many people will have been left up to the end? 5%. Second year 30, third year 50. Means here the percentage is given of people who have left this team. Clear? Understood? 5%, 30%, 50. So at the end of 10th year, no one will be there. 100% who have left. Clear? Now based on this information, what the company wants to do is, here it is written what is the recruitment they should be doing. Now if these people, this many percentage is leaving, so how many people they should hire, and what is the strength? 50 at a time, right? For the running. And 8 senior posts, there are 8 senior posts for which the length of service is the main criterion. 8 posts are there and you have to find out the recruitment policy. What is the average length of service after which new entrant can expect his promotion to one of these posts? Now careful here, what is written here, that you have to find out the length of service. After that the entrant can expect the promotion to one of these posts. So let's start. How do they come about this solution? Now here if you see the first, you will write down the number of years. Clear? Now in this second column you will write down the number of people who are leaving. Now 0, here it is already given, the data is given 0, 50, 30, 50, 60, likewise. So you will write down this data from here. At the 10th year you will have all people leaving, right? Almost. Now do the reverse of this thing. Now how would you imagine that in this year, let's say in the starting of the year, how many people are in service? 100 here. This whole scenario is done assuming 100 people. Remember this thing, with 100 people. Why? Because it is given in the percentage. So we'll start with that thing, that the number of people at the starting are 100. Clear? Now 5% are leaving. So how many are in service? 95. 30 are leaving. How many are leaving? Then 70. 50 are leaving. Then 50. And accordingly you will make this table, right? 100, 95, 70, 50, 60 to 40, 70 to 30, 75, 25, 80, 20. So we both make up to 100%, right? Now, so what is the probability here of leaving? 0. What is the probability leaving here? 0.05. Or you can say that you change this into decimals, 50, or you can say 0.5, 60 or 0.6, 0.7, and accordingly. Clear? Very easy. Now probability of in service at the end of the year. So how do you get this? Again you convert into decimals. 1, 0.95, 0.7, 0.5, 0.4. Understood this table? So what is the next step? Now from this table is given for the 100 people. For 50 people, what is the case? For 50 people it is coming out to be 100 into 50 upon 455. How do you get this 455? It should be the number of people serving in the organization, the summation of this people. Understood? Summation of this people that are working in the organization at the end of 10 years. So how many they should have to maintain the strength of 50? They would have to recruit how many? 11, right? This was for the 100. For 100 the strength is 455, right? So for 50 what would be the strength? That is nothing but 1000 divided by 91, right? If you simplify this you will get around 10.91. If we will take the round figure, which is coming out to be 11%. should be recruited at the strength of 50. If they want to maintain the strength of 50, they will hire 11 people yearly. Understood? But accordingly, if you see here, you will come about that at the end of 10th year, you will have no person in service, right? Now there are 8 senior posts. From table 2, it can be seen that there are 3 people in service during the 6th year. In the 6th year, how many people are there? 3 people are there, right? Now 3 people are in service during the 6th year, 2 in the 7th year, clear? And 2 in the 8th year, and 1 in the 9th year. Hence, promotions of new recruit will be start by the end of 6th year. Why? How many people they require? 8 senior post. 2 plus 1, 3. 3 plus 2, 5. 5 plus 3, 8. So at the end of the 7th, here this you can see here, at the end of 6th year, all this clear. 3 plus 2 plus 5, 5 plus 2, 7, 7 plus 1, 8. For these posts, clear, they will start recruiting, right? And promotions for this recruit, if they are recruiting up to from this, they have to promote these new recruits from the end of the 6th year only. Clear? Now in next lecture we are going to discuss about the game theory. Thank you very much.